again, what we did last class was we introduced some of the properties of radicals, especially just to the simplifying square roots. Okay, but let's talk. Some of this is review and some will be new. So this is the symbol for square root, cube root, fourth root, fifth root. Okay, when you're looking just the symbols, again, the whole process of it, you're identifying, or first of all, as far as the parts are concerned, remember the small number up inside the radical in the top left corner of the radical is called an index, and it represents the power of whatever your simplified radical is, what power you need to take that to in order to get the number that's inside. So if I say this inside number is a 25 for square root, we're looking, since this unwritten index of a square root is 2 square, something squared, okay, what squared gives you 25? And so that's how you solve, because 5 squared gives you 25, therefore when you simplify this, the square root and the power of 2 cancel, leaving just the base 5. Okay, if I gave you cube root, okay, so let's say cube root of 8. So what number can you cube to get 8 is what the cube root of 8 is actually representing. And so if you take, is 8 a perfect cube? It is 2 cubed. And so you get this cube root of 2 cubed is just the base 2 by itself. If I give you fourth root of 81, okay, 81, what you should recognize is you have a perfect square here, right? So you're looking at the fourth root of 9 squared. Well, what do you notice about 9? 9 is also a perfect square, so it's 3 squared squared. So if you think of the properties of the powers here, power to a power, what do you do with the powers? Multiply. 2 times 2 is 4, so you get the fourth root of 3 to the fourth, and that's going to simplify to just your base 3. So what you hopefully can see, even with just these couple examples, is if you take the nth root of some base a to the power of n, that's always going to simplify out to just the base. It's removed from the radicals completely, it's just the base itself. Okay, now, when you're doing this, especially if you're dealing with variables as your bases, if n is an even number, you have to check for absolute value, and which is what we did yesterday. Anytime the index is even, you need to check to see is there a need for absolute values on those expressions. All right. Really quickly before I go on to the actual properties of this, let me just say one last thing, and that is how to express these on the computer. If you're entering answers like this, square root is SQRT, cube root is cube RT. The fourth root, anything beyond that, you're just going to spell that ordinal position. So fourth, RT, fifth, RT, and then put whatever's inside your radical, you'll put inside the parentheses for any of those.